Hi everyone, this is Saiteja from CSC AML. Today my topic is about data transfer modes. Let's get into our topic. Introduction. The method used for transferring information between external I/O devices and internal storage is also known as the input-output surface. Let us discussing about the method for transferring the information between the external input devices and the internal storage is called input interface. We use special communication links to interface the CPU with the peripherals connected to any computer system. We use these communication links to resolve the difference between CPU and the peripheral devices. Peripheral devices such as in the internal the processing devices which in the CPU are called peripheral devices. We can see through the small diagram. In this, we can see the input-output module diagram. In that, we have some components. One is a data register, and the other one is a status or control register. In the data register, the data will be transferred through the logical input device, and in that, the device will be transferred to the external device or interface logic. In that external device, the information will be transferred by through the some buses called as address line, and the other one is the control line. In the address line, the information goes to the information will be transferred with the through the addresses, and in the control lines, which controls the information which we transfer in the through the data register, which controls the control lines will control the data which we transfer from data register to logical unit. Here is the diagram of the input output module diagram. Modes of transfer. The binary information that is received from an external device is usually stored in the memory unit. The information that is transferred from the CPU to the external device is originated from the memory unit. CPU merely processes the information, but the source and target is always the memory unit. Data transfer between CPU and the I/O devices may be done in different modes. Here is the modes of transfer. We can see different type of modes are used to transfer the data. Here is the here we are knowing about the binary information that is received from an external device. The information which is transferred in the form of binary, because the system only understood the binary, but that binary information is received from an external device is usually stored in the memory unit. The information which transferred through the binary information transferred from an external device is stored in the memory unit. The information that is transferred from CPU to external device is originated from the memory unit. The transferred information will be stored in the main memory unit. CPU processes the information, but the source and target is always the memory unit. Data transferring between the CPU and the I/O devices may be done in different modes. Data transfer to and for the peripherals may be done in any of the three possible ways. We can see three different categories of transferring the data in from peripheral devices. First one is programming of input and output device, and the other one is interrupt and initiated input and output, and the third one is direct memory access called as DMA. First one, the programmed input output. It is due to the result of the input output instructions that are written in the computer program. Each data item transferred is initiated by an instruction in the program. The transfer is from a CPU register and memory. In this case, it requires constant monitoring by the CPU of a peripheral device. In the program input and output, it is the result of the input-output instructions that are written in the computer program. Each data item transferred is initiated by an instruction in the program. In this program input, the computer is transferring the data by the instruction of the program. By giving the instruction command, the data will be eh, transferred in the computer. The transfer is from CPU register and memory. The commanded instruction commanded instruction from the computer which help to transfer the data from the CPU register and the memory. In this case, it requires constant monitoring by the CPU of the peripheral devices. In this case, requires the constant monitoring by the CPU of the peripheral. When in the transferring the data from the CPU register and the memory, it requires the constant monitoring, which will observe the data which is transferring from CPU to the memory of a peripheral devices. The example of programmed input device are, in this case, the IO devices does not have direct access to the memory unit. A transfer from IO device to memory requires the execution of several instructions by the CPU, including an instruction to transfer the data from device to the CPU, and stores information to transfer the data from CPU to memory. In the program input and output, the device does not have any direct access to the memory unit. The transfer from input output device to memory, it requires the execution of several instructions by the CPU. By the giving several instructions or commands by the CPU, the memory requires to transfer the data from input device, including an input instruction to transfer the data from device to CPU, and stores the information to transfer the data from CPU to memory. By transferring the data from CPU to memory, it does not have any direct access, but it requires some several instructions or commands by the CPU. Through the commands of the CPU, the data will be transferred from CPU to the memory. Advantages of the program input. Here is a three advantages. A programmed input output is simply to implement. In the program input output, it is very simple to implement. Why? Because we have very less instructions to transfer the data. Simply, we are giving the command through the CPU, and it will be transferred the data from CPU to memory unit. And the next one is, it requires very little hardware support. While transferring, we require very little hardware support. Why? Because in that hardware CPU only, we are commanding the instructions to transfer the data. Mm. CPU checks status bits periodically. In the transferring the data through CPU to memory unit, CPU checks status bits periodically. Disadvantages of programmed input. The process has to wait for a long time for the input module to be ready for either transmission or reception of data. In the programming of input, the processor has to wait for a long time. Why? Because the processor has to check the data which was transferring from CPU to memory unit, so that the processor has to wait for a long time. This is the one of the disadvantages of the programmed input. The performance of the entire system is severely degraded. In this, the other disadvantages, the performance of the entire system is severely degraded, which means it requires more time to transfer the data from CPU to the memory. Interrupt initiated IO device. The next one is The interrupted facilities and special commands from the interface for issuing an interrupt request signal as soon as the data is available from any device. In the meantime, the CPU can execute other programs, and the interface will be keep monitoring the IO device. Whenever it determines that the device is ready for transferring data, interface initiates an interrupt request signal to the CPU. As soon as the CPU detects an external interrupt signal, it stops the program it is already executing, branches to the service program to process the IO transfer, and returns the program it was initially running. In the interrupt initiated, the commands from the internal are issuing an interrupted request signal as soon as the data is available from any device. Meantime, the CPU can execute other programs, and the interface will be keep monitoring the input devices. When we are transferring the data from CPU, it initiates an interrupt to request signal to the CPU. As soon as the CPU detects that request signal and the external interrupt signal it detects, then the data will be transferred from CPU to the memory unit. Working of CPU in terms of interrupts. CPU issues a read command, which means the commands which we using to transfer the data is issued by the CPU, and it starts executing other programs. While receiving or transferring the data, it starts executing other programs also. Uh, Checking for interruptions at the end of each instruction cycle. It checks the interruptions at the end of each instruction cycle. On interruptions, a process interrupted by fetching data and storing it. On interruptions, the process interrupt by fetching the data and storing it. See operation system nodes. It sees the operating system nodes and it process starts working on the program it is executing. Advantages of this are it is faster and more efficient than programmed IO device. It is as we compared from the other device, it is more faster and accuracy while transferring the data, and more efficient. More efficient. It requires very little hardware support. In the transferring, it requires very little hardware support, so it is a main advantage. And the other one is the CPU does not check status bits periodically. In the it does not check status periodically. It is a very advantage to transfer the data very accurately and fastly. The disadvantages are it can be tricky to implement if using a low level language. When you are using the a low level language in the process of transferring the data, it was very tricky to implement. This is the disadvantage. It can be tough to get various pieces of work well together. And the other disadvantages is it can be tough to get various pieces of work well together. The hardware manufacturer or OS maker usually implements it. Example, Microsoft. We can see in the Microsoft, the hardware manufacturers and the OS maker usually implements. These are the disadvantages of this. The third one is direct memory access. The third type of data transferring mode is direct memory access. The data transfer between any fast storage media like a memory unit and a magnetic disk gets limited with the speed of CPU. Thus, it will be best to allow the peripherals to direct communicate with the storage using the memory buses by removing the intervention of the CPU. In the direct memory access, the data transfer between any fast storage media like a memory unit and a magnetic disk that gets limited with the speed of CPU. With the help of this direct to memory access, transferring of data will be faster and faster between the memory unit and the magnetic disk that get with the speed of limited with the speed of the CPU. Thus, it will be best to allow the peripherals to direct communicate with the storage with the memory buses by removing the intervention of CPU. With this direct memory access, it removes the disturbance, and it will directly communicate with the storage with the memory buses by removing the intervention of the CPU. We can observe the CPU bus signal for direct memory transfer. In the diagram, bus request the request and record to the bus request to for the transferring the data in the direct memory access. The mode of transferring of data technique is called direct memory access. The mode of transferring the data is called direct memory access. During the direct memory access, the CPU is ideal and has no control over the memory buses. In the transferring the data, the CPU becomes idle. It doesn't have any work to do and has no control over the memory buses. The direct memory access controls take over the buses and direct manages the data transfer between memory unit and IO device. Due to this direct memory access, the data directly the data will be transferred between memory unit and the IO devices. Bus request. We use bus request in the direct memory access control to ask the CPU to relinquish the control buses. The other one is bus grant. It is activated by the CPU to inform the external DMA control that the buses are in high impedance state, and the requesting DMA can take control of the buses. Once the direct memory access has taken the control of buses, it transfers data. This transfer can take place in many ways. Types of directive memory access transferring using DMA controller. Bus transfer. In the DMA returns the bus after complete data transfer. A register is used as a byte count, being decremented for each byte transfer, and upon the byte counting reaching 0, the DMA will be release the bus. When the D- DMA operates in burst mode, the CPU is halted for the duration of the data transfer. The other one is cyclic stealing. It is an alternative method for data transfer in which the DMA control will transfer one word at a time. After that, it will return the control of buses to CPU. The CPU operation is only delayed for one memory cycle to allow the data transfer to steal one memory cycle. In the cyclic, the data will be after the transferring the data, the control of the buses to the CPU. Return the control of the buses to the CPU. Thank you.